Hello there, I'm Thomas. This is German-American pilot flying the Boeing Boat 787-900 tonight flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 and let's localize the landing zone. Now I'm in the cockpit for the pre-takeoff preparation of the Boeing 787-900 of quality wings and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the pitch ladder decrease and the back angle decrease in the artificial horizon, the vertical rate of climb descent of the aircraft in 10 feet per minute that all the steepness of the trigonometric angles in decrease can climb descent. We have also the Lszh localizer, the horizontal localizer and vertical glide slope. You can see the needles we can follow for using the transmitters, which are positioned in the airport runways we use for takeoff and for landing. The transmitter frequency of the instrument landing system, the Lszh localizers. So we have the onboard antennas inside the aircraft that can receive this frequency display the horizontal and vertical guidance for the runways we use for takeoff and for landing. We have the Zurich International Airport, the runway 14, Lszh in Switzerland. So we're going to use this Lszh localizer frequency. We're going to tune it automatically using the flight management computer. I'm going to show you how to use the flight management computer to create a flight plan or a flight path or a route for this aircraft. So you will see the complete process of every system of the aircraft here, the Boeing 787, inside the cockpit, also the overhead panel. We'll show you how to start up the engines, also how to use all the autopilot flight director system panel, the thrust levers, the flight controls. So we have also in the primary flight display we have the flight director crossbars for manual guidance of the aircraft, the autopilot crossbars for automatic guidance of the aircraft, the angle for attack of the aircraft as it flies in the flight mode analysis with the autopilot and the autothrottle. Later on vertical navigation mode we have also the navigation display, that displays the GPS position, inertial reference position of the aircraft, the magnetic heading and track, the magnetic north pole and true north pole magnetic variation depending on where we are in the world. You can see the horizontal and the vertical profile terrain of the aircraft around you, the terrain map with the airports where they are located. So you can see the airport we are located right now, the Zurich International Airport, and the runway we're going to use for takeoff, runway 14 in Lszh Airport, Zurich, Switzerland. So you can see also the navigation aids, the voice stations, ADFs and DPs, the waypoints which are horizontal vertical navigation fixes we can use for flying the aircraft through using the flight management computer. We're going to select some waypoints. I use them to create a flight plan, so you're going to see how I'm going to do that process right now in a couple of minutes. So I will show you also how to use the navigation display, also as it also display the other aircraft that fly around you. We have the transponder, the ADS-B and ADS-C transmitter receiver that transmits our frequency to other aircraft and the air traffic controller, and also receives from other aircraft, and this way displays the other aircraft with the diamond shape in the navigation display. You can see the other aircraft distance, where they are located, position, direction with your aircraft, with respect to your aircraft, whether they climb or descend with respect to your aircraft. Also, you can calculate the velocity closing in between your aircraft and the other aircraft. So if we have an incoming collision, it will give us a warning using the TCAS system, the traffic collision advisory system. So you can see here we have the switches for all these things. That's above the navigation display. You can set traffic, terrain, and weather radar. We have the range, we have the barometric altitude here in inches of mercury or hectopascals. So you can see we have the barometric pressure here, 29.92 displayed digitally. We can change that if you need. The radio altitude, so every value here displayed with purple color, magenta, we can change it to other values. Also the the barometric pressures, you can see the terrain 4000 1800 minimum, maximum minimum values with red, yellow and green, and also blue for the sea. I'll show you in a couple of minutes. We have also the airspeed indicated here. For now it's 30 knots. The airspeed selected, the altitude selected, the barometric altitude above the sea level, the pitch ladder in degrees, 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20 for pitch up or pitch down. The radio altitude above the ground level, the bank angle in degrees, how much steep turns you want to take, the takeoff ground modes in the flight mode annunciator arm, the HSI, the horizontal situation indicator, the magnetic heading, the track, magnetic north pole to north pole. So you can see here the navigation display, we have magnetic north pole here, the plan. I'm gonna display in a couple of minutes. Here you can also select other values. You can see the cursor moving using the mouse. So we have also the engines indications here. I will explain in a couple of minutes. So you can see the thrust levers when I move the engines forward. You can see the engines indication increase or decrease over here. So you can see the commanded position right now. You can use full takeoff. It takes like 3 seconds for the engines to react, reach the maximum takeoff. You can see also the red warnings, the configuration warning. We're not configured for takeoff yet. So we need to set up a few things in the aircraft. The flight management computer, as I tell you here. You can see the mouse pad here. We use also for the cursor display. So we're gonna use the flight management computer in a couple of minutes. So we use the flight management computer. I input all the data of the aircraft for this flight. That includes the takeoff gross weight, the empty weight plus the passenger plus the cargo plus the fuel on board, the trip fuel, the reserve fuel, and the taxi fuel. Where the fuel is stored on the left and the right wing. How much is like 30% right now for this flight in its left and right wing tank. The center tank, if it is balanced between the left and the right wing. Also the cargo in the compartments and the passengers. The flight management computers can calculate this way automatically the center of gravity of the aircraft for this flight, and the mean aerodynamic chord position of the forward wings is 23% of the Mach, the mean aerodynamic chord of the forward wings, where the maximum aerodynamic lift occurs in the forward wings is also the position where the stall will begin in flight for giving an angle of attack. The airflow will become detached from the top surface of the wing, so we need to pay attention over here to monitor here the stall speed all the time. As you can see, here's the airspeed. We have the stall speed displayed with red and yellow indications just below the airspeed over here. So you need to pay attention to that indication, the stall speed. You can see also here the wings of the aircraft. I will explain you now the Newton's physics, aeronautical and aerospace engineering. You can see the mean aerodynamic chord position. 23% of the Mach is pretty much here, with the maximum aerodynamic lift occurs in the wings, also where the stall begins. We need this for flying the aircraft. The aircraft wings hold the weight of the aircraft as it flies, using the forward thrust propulsion from the engines to keep it moving forward. We have the center of gravity here, pretty much with the mean aerodynamic chord is 23% of the Mach. You can see the flaps are extended. Also the speed brakes are now. We can retract the speed brakes like this. So we have ailerons, spoilers, and so over here also the flight controls. Make turns in flight. We can climb and ascend also using the elevator from the tail. Use the horizontal trim stabilizer. So we have the lateral axis from wingtip to wingtip, the longitudinal from nose to tail, the transverses over here, the horizontal tail of the aircraft. So you can trim up or trim down the aircraft tail as you want to fly the aircraft, to balance the aircraft in flight. So we have the longitudinal axis from nose to tail, the lateral from wingtip to wingtip, and the vertical transverses the center of gravity over here. So I'm gonna show you a few more things. So this is the Newton's physics and Bernoulli theory of fluids. You can see the bottom surface of the wings. Over here is more flat, so we have higher as the airflow. We accelerate for takeoff. The airflow of the air is moving much slower using the burning material fluids below the wings. So we have much higher pressure, which pressurizes the aircraft weight and up into the air, and the wings up into the air. And this way we take off and fly. So you can see also the top surface of the wings. It has higher curvature, so the airflow is moving much faster using the burning material fluids above the wings. So we have lower pressure above the wings, which sucks the aircraft wings and weight up into the air over here from the left and right wing. So this is the main principle you need to know about the aerodynamics of the aircraft flying, aerospace engineering. You can use it for the air transport pilot license. So you can see the flight controls. I'll show you right now. So we have the flight management computer over here. I'm gonna create a flight plan. So I use the takeoff cross weight of the aircraft for this flight. As I told you, the flaps for takeoff 15 degrees. We're gonna use the mean aerodynamic core position is gonna be 23% of the Mach using the fuel on board. The takeoff cross weight is gonna calculate the center of gravity using the left and right wings, fuel tanks, the center tank, and load compartments, the cargo load all over the aircraft, and the passengers. So we have also the this is gonna give us the horizontal stabilizer of the aircraft tail trim position. We need to trim the horizontal tail of the aircraft from takeoff, climb, cruise, descent, approach, and landing all the time, either manually using the horizontal trim stabilizer switch over here in the flight controls in the control wheel. You can see here we have this trim switch. I will show you right now. We can trim this way the horizontal tail of the aircraft. Either this way is gonna be trimmed down, and this way is gonna be trimmed up. So we're gonna trim the nose of the aircraft up to give us an up moment. This down moment. We have also the head-up declutter switch, the autopilot disconnect here, a few more switches. So this is for horizontal tail trim stabilizer, elevator trim, left click down, right click up. So this is the elevator trim. So we trim the horizontal elevator of the tail of the aircraft like this, up and down. So it will give a balance of the aircraft, a more easy flying, less pressure in the flight controls also. So you have also over here, I will need to go in a couple of seconds to the flight controls. You have the alternate over here pitch trim. If you have failure of the normal maybe channel, you have the alternate, because so this is nose up trim, this is nose down trim. So you can see the trim for the horizontal tail elevator. You have also the parking brakes here, you can set like this. So we have also the horizontal trim stabilizer. So you trim the horizontal tail again over here, up and down. So you have the autopilot here and auto throttle, and also the auto throttle over here and the flight director. So you have the fly-by-wire system of the aircraft, and this is a fly-by-wire aircraft. It has an auto trim function by itself using its flight management computer and flight control computer, so it can balance itself on its own. You can also use the trim switch to balance it yourself. This is the manual only trim channel. So this is the automatic. If you have a failure here of the L2 or R2 hydraulic systems, over here you can see it says hydraulics. So I will show you later how to use these hydraulics, electrics, fuel system, engine, electronic engine control, auto start over here, pressurizer. So we're gonna need some systems later. So we have the hydraulics failure, the autopilot and the flight director and the auto throttle fly-by-wire system is gonna have failure with the automatic trim of the aircraft. So you come here, you open this guarded switch, red guarded switch. You see left L2 stabilizer cutout switch guard. So this is the left and this is the right stabilizer. you need to turn from normal to cut off. You have a failure of the hydraulics of the L2 or R2, either one. So you need to do that. You're gonna lose the automatic trim. You will only gonna have the manual trim switch over here, so you can trim manually the tail of the aircraft all the time, no matter what. So this is for all the Boeing 737, 747, 757, 767, 777 and 787 aircraft. The stabilizer trim cutoff switch pretty much the same, not much different with one another. So you can apply also the elevator here. I will show you in a couple of minutes. Maybe I need to show you how to input the flight management computer, how to create a flight plan. I will show you in a couple of minutes. Then I will show you the flight controls, how to use the flight controls using the Lszh 6. So I will show you now the control of the flight management computer. In the pedestal we have the control quadrant in front of the pedestal. So here you can see another view of the aircraft also, of the Boeing 787. So you can see here we have the initialize, the index identity over here, Boeing 787, the model, as you can see, index position here. So you're using the reference position, the reference airport, Lszh. It will give you the GPS nearest position to you, which is for the reference airport that we are located right now. Last position. So we have over here some values, some modes we can use: performance, takeoff, approach, annunciate status, navigation data, flight plan, load ATC, route, load plan, save flight plan. So we use over here initialize the route from this airport, the Zurich International Airport in Switzerland, the Lszh, copy paste back to same origin, same destination over here, as you can see. So clear the discontinuity over here, runway 14, departure over here, and arrival. So you can see departures, arrivals over here. Select runway 14 for these seeds. The seeds are the standard instrument departure waypoints and fixes we use that include horizontal vertical navigation fixes for the initial climb of the aircraft. So we have departures, arrivals, ILS localizer. You can use VOR if you like. I like ILS. Transamity. You can use also other runways, and Transnegria. This is a convenient route for me. That's what I'm using every time. So we have the route here created. We need to cancel a discontinuity in the Amity waypoint, so we copy paste one another. So we need to add some values here. You have the so you have the legs here already created but not yet active. This is the waypoints we have to cross through the flight plan. So we have here the takeoff gross weight, 0 fuel weight, plus fuel on board. So we have 322,000 pounds plus 35,000 pounds, gross weight 358.9 thousand pounds, the reserves 5%, cruising altitude 25,300. Over here the cost index 100%. You can see the fuel temperature at which the fuel will freeze in flight, minus 37 degrees, so we need to recirculate the fuel into the engines to heat it up. 38% center of gravity in flight, so we execute that. It will activate like this the route, as you can see, displayed with magenta color right now. So we have to use only the flaps for takeoff, 15 degrees, center of gravity over here is gonna be calculated automatically 23% using the flaps. So you see here the values, and this give us over here in the takeoff ref the V1, V rotate, and the V2, the takeoff speeds for this gross weight, for this runway. So this is the route completed. Over here the legs, so you can see the first leg, 1900 feet. It's bearing 135 degrees heading, magnetic north pole, 2 nautical miles away from the runway threshold. After we take off, we need this airspeed, so every step after is a waypoint we have to cross through. As we climb, Zui 302, 6000 feet, and then Nigria 302 knots, flight level 32,100. Then Mativ, we need to start descent, 320 knots, 11,800. Then we have the approach, the stars, is other terminal arrival waypoints and fixes, again Namiki, Zui. Then TRA C1 CI14, TRA 5,180 knots, ASIR 14, Osnem, and the runway, the arrival runway 14 in the Zurich International Airport. So we have here initialize route, departure arrivals, alternate, active 240 knots, the VNAV over here, progress, FMC communication, hold, you can hold in flight at some waypoint over here. As you can see, you can use also fix. You have the navigation radio. So we go now for the rest of the systems here. Before going into flight, I'm gonna show you what we have created. By now we have a flight plan created. So flight plan. So we have a flight plan created, an active route or a flight path. You can see its legs here. We have created. You can see also the flight management computer will give us different indications here. Now we have flight director on with different values. We can change some values from the autopilot flight director system panel. So you can see again we have the same airspeed and altitude selected. Our indication right now, we have the intercept first waypoint here we have to fly through. The runway, we're gonna use the takeoff, the flight path in flight, make a turn, right turn, another right turn, then a left turn, approach and landing. So the first turn is left, then right, then again right, then left, and approach and landing. So we need to cross through some waypoints. You can see also the vertical profile of the flight here we have created. So this is the aircraft right now in the runway, 1,400 feet. Then we're gonna be flying higher, like 35,000 feet. Over here you can see we need to follow this purple line in flight. Also here the horizontal, you can see the terrain. So we change over here, you can change the barometric pressure, you can change the range, the minimum radio, the plan, the indications. So we look further closer, you can see the stars here, the arrival. We have to cross through for approach and landing. So we look even closer, you can see the terrain now much better in front of you, like in 5 nautical miles you will see you have some mountains over here, and we have to climb through with this angle. You can see the runway better. So you see the mountains in front of us over here, okay, the terrain, and further away you see this terrain horizontal in the map. You can see also red, green, yellow. So we have the runway also here in the GPS display that we are located. The runway we're gonna use for takeoff. You can see the aircraft orientation, the taxiway, and the other runway 16. So this is the international airport. You can see the runway 14 over here, the taxiway in front of us over here displayed, and the other runway. So you can see also here everything matches the one displayed over here in the GPS display of the aircraft. So you see we have the runways here, all maps over here in the GPS. So we have also to see a couple more things. Then as we're gonna be flying, we're gonna follow the flight flight path we have created. Over here you can see also the center looking display. Maybe you see better the waypoints we have to cross through, how far away I'm gonna be flying over here, then return back for landing. And also the plan display over here, better view of the plan. You can see the airports, how far away you want to see. LF, EDSB, LF, JL, some indications here also. So you can see here better the map display with the waypoints, a more clear view. So we have it here, all the indications we need for flying the aircraft. And the aircraft just beside us. You can see the distance ring over here, 0.15, 2.5. So you can see better the flight plan we're gonna use here for takeoff, then climb over here, this purple line. You can see also the indications from the engines. I will start explaining in a couple of seconds. Over here, some other functions of the aircraft. So this is all we need to know until now for the navigation displays. You can see also we have over here in the overhead panel, we have the air data computer. You can see heading reference, IRS inertial reference system, primary flight control computer, flight control. So we need the air data computer over here to display the pitot static and pitot dynamic for the airspeed, the pitot static for barometric altitude difference as we climb the nose with descent, the laser gyroscopes, the GPS receivers, laser gyroscopes, inertial acceleration, deceleration of the aircraft, the altitude in flight, magnetic north pole, true north pole, magnetic variation depending where you are in the world, the altitude of the aircraft above the ground, radio altitude. So all these indications, the angle of attack as it flies, the pitch attitude in flight. So everything is affected by the air data computer for the pitot, also static and GPS receivers. And we have a few more things to see, the flight controls here. So also you know the flight controls of the Boeing 787. I will start the explanation of the flight controls of the Boeing 787-900 aircraft. You're gonna see now how I use the side stick to control the horizontal elevator for climb descent. I pull up towards me the elevator, the control column, and pull away for descent, and also make bangles left and right using the control wheel on the rudder pedals, using the vertical rudder, also for nose wheel steering and for braking on the ground. So you can use also all these functions. Here we have the horizontal trim stabilizer. So we have in the we have in the rudder pedals, we have also the tiller interconnected until like 76 knots. In takeoff is going to 0. Then we have only the rudder. The rudder is becoming aerodynamically effective at about 45 knots in takeoff. We have also the toe brakes and top surface of the rudder pedals. Also in all the flight controls of the Boeing 787. So I use the side stick over here. As you can see, the Logitech Extreme 3D over here. So you can see I can climb and I can descend. I move the vertical column over here of the yoke up and down. Use the control wheel over here to make turns right or left. I can use all flight controls together, or on the control wheel or the elevator. So you use also the rudder pedals, as I told you, to make turns right and left. The rudder join turns, the vertical tail of the aircraft over here. So you make turns right and left using the rudder pedals, and the elevators using the control column for climb and descent. Also ailerons and spoilers using the control wheel. You can see the ailerons moving up and down to change the aerodynamic between the left and right wing, make the aircraft turn in flight. Also use the rudder, vertical tail. So we have all these controls. You can see both side sticks, both yokes actually are interconnected. The captain and the first officer, they move together in flight. Not like in the Airbus, you have the side stick priority. Unless we have a failure in flight, you have like this. We have also the tiller, we have the horizontal trim stabilizer, the alternate trim, as I told you. We have also the thrust levers, we have the flaps position here. You can see the flaps handle. We can position the flaps like this, which are secondary flight control, or down, fully retract, fully extend. You see how many degrees. Also the speed brakes here, extend and retract. So you see the flaps position. Over here it displays also the horizontal trim stabilizer, flaps, stabilizer trim, and rudder trim. We have the landing gear also extend and retract. I'll talk to you about later. So we have all the flight controls like this, the speed brakes, horizontal trim stabilizer like this. So I will show you also one more view of the flight controls. I will show you also the thrust levers and on the outside view using the flight controls of the Boeing 787 very quickly. So you're gonna see now we have here also this view of the Boeing 787 flight controls. So you can see I can use all the flight controls like this: climb and descent, just like the Airbus, left and right turns. You can leave neutral. Also use the horizontal trim stabilizer like this. You can see climb and descent, make turns left, make turns right. Use the rudder pedals like this and the horizontal trim stabilizer. Also we have the thrust levers like this here. This is the thrust levers moving forward and aft over here. So this is how you use all the flight controls. We're flying the Boeing 787. You will see later in flight we can climb like this, descend, keep balance, leave neutral, and trim the horizontal tail position, also the outside view, left and right turn, climb, descent, make turns left and right. So this is all the flight controls. You see also the tail over here I use for climb and descent. So this is descent, this is climb. Over here you see the tail and the turning tail, the yaw of the rudder pedals. So we have also the spoilers retracted. You can see again ailerons and spoilers, deflection. So we need also now a few more things. So we have, I think this is enough for the flight controls right now. I will show you the thrust levers, the engines thrust produced. So we have the GMX engines installed in our Boeing 787-900Z aircraft, one left wing, one right wing, full symmetric thrust and one right Z engine produce a lot of thrust. We have also the fatigues installed in the gearbox. of the engines. The FADEX are the full authority. These are electronic control computers. One installed forensic gearbox, dual channel redundancy, one channel plays the other takes over. Controls, monitors, and displays all the engine data using the upper and the lower ACAS. As the indication system display, all the multifunction display. You can see the N1, which is the low speed starter, low pressure compressor, and turbine of the turbofan turbojet engine, the exhaust gas temperature engine, the N2, which is the high speed starter shaft, the high pressure compressor, and turbine of the turbofan turbojet engine, the fuel flow principle of 1000 kilograms or 1000 pounds, oil pressure, oil temperature, quantity, and the vibration of the N2 stage of the engine. We have also the outflow valves from the 5th and 9th stage, compressor stage, high pressure compressor, which admits pressurizer from the engines. Also we have the leader from the bypass front fan stage. So you can see here, I will turn on from automatic to manual the pressurizer here, so you'll see what happens. We turn to manual, the pressurization, so we'll display something in the display for the engines. Also you can see with amber the cabin altitude, auto, outflow valve, aft and forward over here. You can see also here the outflow valve's position, cabin altitude 1400 feet, rate of climb. So when we climb to like 40,000 feet, the cabin altitude inside the aircraft is gonna be like 8,000 feet. So when we have also differential pressure like 7.8 or 8 psi maximum for the cabin pressurization system that takes pressurizer from the engines or the APU as a backup. So I'll show you also that. So we have a few more things to note. So the engines here, the displays. The FADEX also tells you the pressurizer from the 5th and 9th stage, from the outflow air valves. You have an overpressure and under pressure in the engine, so they can open and close the outflow valves into higher or lower position. To increase or decrease the pressure inside the engine, also they can close automatically like the packs in takeoff to increase the pressure inside the engine for having more thrust for takeoff. Also we need also the FADEX control the fuel flow to the engine, fuel metering unit, oil heat exchange sensor. If we have the oil heat exchange automatically, so we need to recirculate the fuel in flight from the tanks, from the wind tank, left and right wind tank and the center tank into the engine components, deduct heat from the engines and cool down the engines, and also heat up the fuel, because if we fly into higher altitudes above the sea level or the airport elevation, we're going to be having the fuel freeze at minus 37 degrees Celsius, and we fly at much lower temperature. So we have also the oil heat exchange sensors and the lubricant exchange recirculation system into the engines. We have also the as we climb higher the aircraft from the sea level, like 20, 30 or 40,000 feet above the sea level, like 8,000, 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we climb higher and higher, the pressure of the air, the oxygen level and the density of the air becomes less than half than that of the sea level. Also the temperature of the air will become freezing, like minus 30, minus 40, minus 50, minus 60 degrees below zero in Celsius. And also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. So as we climb higher, the aircraft will be flying faster, and it's going to have a higher intake of air flow from the front fan of the turbofan turbojet engines for compression and combustion, and this will make the engines demand different fuel air mixture requests every second. This is adjusted also automatically. We have the automatic adjustment of fuel air mixture requests every second from the FADEX. The full authority is the electronic control computers, as I told you. So it's a good thing to have the FADEX installed to your engines. This is also done vice versa as we descend back to the from the cruise level to the elevation of the airport or the sea level. So it's better than doing that manually like you do in the trainer aircraft. You have the automatic fuel mixture every second and pressure adjustment inside the engines and other adjustments. So we have also over here we have the EPU. I'm gonna show you how we're gonna start. The EPU is a smaller auxiliary auxiliary power unit, smaller turbine in the tail of the aircraft, located in the tail cone of the aircraft. So we're gonna be using it when we're gonna turn off the engines in a couple of minutes to make the engine start demonstration. So I was talking about the engines, the fatigues. So this is all the cool things you can do with them. I will show you also the displays, what you can see here from the fatigues display right now. So you can see here we have the display like the N1. You can see 19.7% is the idle thrust. It's the low speed starter shaft, the low pressure compressor and turbine with the turbo fan to descending, the left and right. The takeoff limit 100.4%. The exhaust gas temperature per engine. The N2, which is the high speed starter shaft, the high pressure compressor of the turbo fan to descending, the left and right. The fuel flow per engine per hour 1000 kilograms, 1000 of pounds. Right now 1500 pounds per engine per hour. Oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. The outflow valves, as I told you. Other things, some warnings here. We have the gross weight here. The outflow valves, cabin pressurization system. Bleeder also, gross weight, total fuel on board for takeoff indications. So you can see here we have the landing gear extender retract indicated also. The alternate gear lock overrides, a standby display over here. The auto brakes here, if we set rejected takeoff, you'll see the auto brakes rejected takeoff here display with white color. Disarm, so we can disarm the auto brake, rearm it, and also use for landing, like one auto brake, 1, 2, 3. So we have some other indications. Also, I forgot to mention that the outflow valve, the pressurizer from the engine, which is controlled from the fatigues, is also supplied for the hydraulic fluid tanks pressurization. All the flight controls that I show you are commanded electrically but are actuated hydraulically. We need hydraulic power from the engines, compressors, pumps, and also from the hydraulic fluid tanks, which are pressurized with air from the 5th and 9th stage of the engine. So we need pressurizer for hydraulic fluid pressurization with the engine, the air conditioning, ventilation, oxygen regulation inside the cockpit of the cabin, and cabin pressurization of the aircraft as we climb on the descent. So you see the flight controls. If I move the yokes here, you see everything is moving. We need hydraulic power from the engines to move the wings around. So the tail, the rudder, the speed brakes, flaps, landing gear extender retract, parking brakes, auto brakes, thrust reverser for the engines. Everything needs hydraulic fluid pressurization. Over here you see the hydraulic fluid tanks, hydraulic fluid pumps actually, engine driving and electric driving. So this is all the things we need to know. So we need also pressurizer to start the engine. We're gonna start the APU in a couple of minutes. Also now the autopilot flight director system panel, last thing before showing the overhead panel. So we set autopilot flight director system panel. Here you see auto throttle left and right, arm and disarm, the airspeed select knob here, the LNAV and the VNAV if we arm, LNAV and VNAV here. This is the airspeed guidance, the autopilot engage, disengage, the auto throttle left and right, the flight director. If we disarm the flight director, we cannot rearm the autopilot or any mode of the autopilot. We need to have the flight director arm all the time. So we change the airspeed like this, like 253. Autopilot disengage, you see here, pull out. Flight level change, so the throttle climb continues. We're gonna use the magnetic north pole heading of the airport, the bank angle in flight also. So we select heading 136 degrees. You will see everything displayed later in the autopilot flight director system panel. 136 degrees. VOR localizer, approach for autoland. Over here, altitude select 1000 first, 25,000 or higher. So then hundreds. We can use also flight path angle here or vertical speed. So we use vertical speed. You move this cursor down. You'll see how fast the aircraft will descend. You see the minus sign. You will see everything now displayed in the primary flight display. We have zeros, level off. You can climb also like 3,500 per minute. So you see now all the indications are displayed here in the head-up display and the primary flight display for navigation purposes. So we have the airspeed selected, then the altitude selected, flight director, vertical rate of climb descent, other modes, and nav. So we have the overhead panel. We need to start the APU very quickly. I'm gonna make an engine start demonstration. We have the left and right IDZ, the grade, rise and radio, 120, 400 volts, 120, 200 volts, 400 Hz frequency, 108,000 kilovolts, the battery. We're gonna see in later display. Primary flight control computers in the auto position here, air data computer, flight control surfaces, FT door here, towing power, oxygen, passenger oxygen, window heat, rammer turbine, has a backup for hydraulic fluid power. You turn off hydraulic engine driving. You see what happens here. The fault is displayed, so we turn it back on, then to the auto position. We have the wing and engine ADIs here. Over here you can see. Actually we need on or auto. Also we have the lighting system of the aircraft, the windshield wipers. We have over here the recorders, the cargo and engine fire, electronic engine control for the engine, and the auto start. Over here we're gonna use the auto start later. We have also the fuel jettison. We get down some fuel in flight, select the nozzles and how much to remain if we arm these. Fuel pumps, left and right wing, center tank, and the crossfeed. We can use the crossfeed to feed either left and right wing with either pump or either tank, or we can balance the fuel if we need. We have the balance also over here. So this is the fuel system. We have also here the packs, the pressurizer from the engines and the APU, air conditioning, ventilation, oxygen, and cabin pressurization here. We use the outflow valves, open and close, and climb descent, and use the automatic mode, normal and alternate. So this is all the overhead panel you need to know just before. A few more things. Fuel control, left and right engine, auto throttle here, disconnect. This switch disconnects the auto throttle. We have the fire extinguishers for the left and the right engine, pull out and switch, transporter, rudder trim, radio and communication panel, and also thrust reversers here for the engine. I will show you later. And last thing, the systems here indicated in digital format, all the systems you will see now. Hydraulics, APU, oxygen and liquid cooling, electrics. So we have 120 to 100 volts, the contactors of the IDG, the APU, how much also load shed, and main battery over here 31 volts. Hydraulic systems here, left and right engine, electric C1 and C2, where the hydraulic fluid goes, and the pressure 5000 psi system, the quantity of hydraulic fluids out of valves, left and right wing, fuel tank, center tank, fuel booster pumps forward and aft. The crossfeed valve is off, but if we turn it on, you can feed either engine over here with either pump or either tank. We have the low and high pressure fuel valves open and feed both engines. We have the recirculation of fuel in flight, as you can see here, because we have the minimum fuel temperature in flight is going to be minus 37 degrees. So recirculated automatically using recirculation system. The temperature of the fuel right now, how much fuel you have, 11,000, 11,000, 11,000, total 34,200. The APU is fed from left wing using the DC motor. The air pressurizer packs left and right engine, APU also. Doors are closed and the cabin can be pressurized. The landing gear, nose wheel, the temperature of the brakes, of the pressure of the tires. Flight controls, here you can see we can move The controls like this, either way, other side, climb and descend. So this is the flight controls display here in digital format. All the wings, you see you can climb and descend. You see how much steep turns, angles it takes for the flight controls. As you see, the ailerons and the spoilers. So we have the FS display, maintenance, systems, maintenance also. It's automatic checklist over here. What to do in the checklist before takeoff, after takeoff, cruise, descent, approach, landing. So we have navigation display again. Turn off the engines like this. We need some lighter, so I'm gonna turn off both engines. So both engine control, you can see here, both fuel control to the off position. You will see a lot of systems are resetting right now, as you can see. So we have both engines off, we need to restart them. So we go over here in the overhead panel, very quickly set both auto start to the on position. Like this, you will see the amber indication, engine control, auto start. So we start the engines. You see pressurizer is admitted from the APU right now, 20%, 20.3, 0.7, above 20%. We have pressurizer here into the engines. You can hear the roar, but we need also the fuel. So we'll let both fuel control, left and right, on. So you have the auto start now kicking in. Fuel pressure 35%. So you see the engines are roaring. We start. We have both pressurizer and fuel. So you see the systems are coming back to life. Both 55%. We need one more 60%, 61. We have the engines, both engines running. You can see. Now we can go for takeoff. Flaps 15%. Parking brakes off. So we're gonna have also the view for takeoff. Advance the thrust levers like this. And we taxi for takeoff. Idle thrust. The runway is open for us, as you can see. Have no traffic, and we take the air traffic control clearance. So we align with the runway here. Advance the thrust levers over here. Takeoff, full takeoff power. And we have begin the takeoff process. We pull down a little bit 100 knots, 120, 130, V1. We have we rotate. We start the rotation, less than 9 degrees of pitch attitude for rotation, a pitch trim a little bit. So we have the initial climb, landing gear up. So we keep climbing. So we climb over here, as you can see. You can see the indications that we follow. We are 2,100 200 feet above the ground, but 3,800, 2,400 above the ground, 4,000 above the sea level. We have a difference between the sea level altitude, the pitch altitude like 5 degrees, the airspeed 211 knots, the stall speed here, you can see we climbed here the needle, and the pitch altitude now is 15 degrees. You can see the terrain, red, green, yellow, the flight plan here, we have to follow. So you see better view of the terrain, and the vertical also profile. You can see the terrain over here below us, how far above the terrain we are right now, less than about 7,000 feet. You can have also the stall speed now, the thrust from the engines. So we have here to look outside, beautiful view as we fly from the airport, the Switzerland here, the lakes, the Swiss Alps. So we need to start maybe the turn now. So we're gonna begin the turn like this. So you can see I can use also the head-up display for indications, and we have 16 more minutes for this flight. So we climbing like this to balance here. We need to follow this Mazzetta line, the flight line. You can see the airspeed now is very close to the stall speed. You can see also the head-up display displays the same things. Also the autopilot flight director system panel, the flight line, and now the engine indications like this. Maybe we need to retract some flaps to accelerate the aircraft to higher airspeed. So this is a nicer view of the cockpit inside after the takeoff. How it does look like, how bright it is. Perhaps we can retract the flaps more into a higher setting. Maybe retract completely. We'll try and see if it works out. We will accelerate very fast, climb faster maybe, but we need to pitch down the aircraft a little bit to accelerate. So now you can see how close we are. 194 knots, the stall speed, the yellow marking, it's the warning. 160 knots pretty much is the stall speed. So we need to pitch down a little bit. So we need to turn here for the flight one. So we have a beautiful view here of the Switzerland, also the galaxy here, the aircraft will fly around us. The lakes here, we have the beautiful lakes, the Germany, the Bayern Munich, my homeland, the Germany, and the France here. So take the turn, and we keep climbing as much as possible. So you can see we follow the flight one pretty much accurate now. Also the engine indications here, and the other side here. So we need to make a turn here, a small turn, to align with the Mazzetta line of the flight plan we use. I don't know, maybe a little bit more flaps. So we have 12 more minutes left for this flight. So we're gonna begin the turn in a couple of minutes. You can see we follow the purple line here that we need. From the outside also, beautiful view over here, and the aircraft, the lake, and Germany in front. So we have 11 more minutes left for this flight. You can see also the vertical, the cruise level that we are right now flying. We look further away, see a couple more things. So perhaps we need to start the turn now. We climb through to the 4,000 feet. We're very close to the lake here, as you can see. The Germany, the lakes, beautiful lakes over here. The Bayern Munich, my homeland over here. So this is the Boeing 787. Beautiful turn here. 24,000 feet. 925,000 now. And we're gonna increase. We have the Germany, Bayern Munich, France, Italy, Switzerland this side. So we need also to use some rudder pedal as we turn. So we cross 25,000 feet now. Over here, 25,500. Keep turning. We need to align with the flight plan, so we make a little bit steeper. Use more rudder over here. Steeper turn and faster turn also, and align here. So pretty much level off. We need to climb a little bit higher. As you can see, all the indications. A little bit higher climb, and also retract maybe some flaps to increase the airspeed. So we flying 26,300 feet. Now we're gonna be having the chemtrails for you for this display. You can see the frozen vapors. We have 36,800 900 feet over here. The France in this side. Beautiful view. And the galaxy, beautiful galactic view. We are flying the Switzerland, the lakes here, the Germany behind us is Bayern Munich, and we reached 27,650 feet. We need to start the descent in a couple of minutes. So we're gonna stay with this view. We need to initiate the descent. We have 7 more minutes. So retract all the flaps. Thrust maybe more idle and pitch down the aircraft for descent. We keep flying manually over here. have 7 more minutes for this flight left, so we need to get a little bit faster into the airport. And also there's maybe some speed brakes to descend faster. So this is a beautiful view again of the cockpit of the Boeing 787 over here. So you can see the line here very more clearly how we need to follow and enter the runway heading for landing. We descend faster and advance maybe advance levers. And we have 6 more minutes left for the approach and landing as we are descending over here. You can see. So this is our descent and approach over here. And we need 5 more minutes for the approach and landing. As you can see, we have max 0.695. We need to start turning now. Idle thrust over here. So we need to start the turn now. For the approach, use some left rudder. Keep descending. So we pay attention to the instruments as we descend like this. Let's use maybe somebody here. Slow us down. Accelerate the descent. So we need to descend faster, as you can see, and align with the runway heading over here. So we are into the runway. Landing gear extend. Flaps also. Some flaps extend. So we have the runway heading. Over here you can see the display. We need to align ourselves with the runway like this. So use some left rudder now, as you can see. And use a few more flaps in a couple of minutes. As you can see, we are approaching the runway for landing. So we are in a very good, nice position. So we're gonna see this view for landing. And we have 2 more minutes left for the approach and landing over here. We descend a little bit faster. Use a few more flaps. Full flaps. And align manually, as you can see. Idle thrust now. You can see the ILS localizer here. All the indications are correct for the approach and landing. The airspeed, altitude, the glide slope also. We need to follow, so we add some power now. Some thrust. So we have some side wing we need to align using all the flight controls, aileron, spoilers, control wheel, control column. Also the rudder pedals, use a lot of rudder for align with the runway over here. Use a little bit more thrust whenever needed. So we're gonna be aligned here. We have the flare here, as you can see, flare for touchdown, flare the aircraft, as you can see, and touchdown, beautiful touchdown. Here we are. So we have parking brakes and thrust reverse, like this, full thrust reverse. So we keep aligned with the center line. As you can see, we're slowing down. Full thrust reverses. We're slowing down, very beautiful landing over here. How much runway we still have remaining. So you can see all landing gear here is perfectly safe. The nose wheel, there is no breakage. The landing gear behind it. Also, so the aircraft is standing up in its wheels. You can see there is no breakage of any wheel, of any part over here. You can see all the wheels. Also the forward wheel over here. The nose wheel. So we cancel the thrust reverse like this. You see the thrust reverses are coming in. Everything is normal. So that was